In this video, I'm going to show you how you can deploy a large language model that was fine-tuned with QLoRA on a HuggingFace Inference Endpoint, and I'm going to show you how you can query the API in order to get responses to your prompts. Hey everyone, my name is Venerin, and in this video we're going to answer the question: how can you deploy your large language model that was fine-tuned with LoRa or QLoRA to production? First, we're going to start with the PEFT model, and we're going to merge the QLoRA weights with the original Falcon 7B model. So we're going to merge those. Then we're going to take the original tokenizer and some supporting files and upload all of those to the HuggingFace hub. Finally, I'm going to show you how you can use inference endpoints by HuggingFace in order to deploy your model behind a REST API. We're going to use a custom handler that takes the prompt as an input, creates a pipeline based on our model and our tokenizer, and we're going to return some responses. At the end of the video, I'm going to show you how you can use the request library in order to send post requests to your API or your model and get responses in the form of JSON. Let's get started. There is a complete text tutorial for ML Expert Pro subscribers, and it is available within the prompt engineering guide, Deploy LLM to Production. And here you can find a complete text along with the code that we're going to run through. And there is a link to the Google Colab notebook that you can find on the GitHub repository right here. So if you would like to support my work, please consider subscribing to ML Expert Pro. Thanks. I have a Google Colab notebook that is already running, and it has 16 GB of VRAM with a Tesla T4 GPU. The model is already loaded, and you can see that pretty much all of the GPU RAM is already taken by this model. Also, I'm using the high RAM option right here, which you can turn from the change runtime type and then high RAM option. Unfortunately, you will need Google Colab Pro in order to run this, so keep that in mind. The first thing that I do is to install all of the available or required dependencies. Here you can see the torch, the bits and bytes library, the accelerate library, etc. Also, I'm doing all of the necessary imports, and the next thing that I do is to walk within the HuggingFace hub so we can upload our resulting model there. So the first thing that I do is to get the files from this repository that we did in previous video. This is the QLoRA chat model that we fine-tuned. And here you can see that we have only the adapter config and the adapter model, which are the model or the weights for the QLoRA adapter for our model. So we're going to take this. So I'm loading this into a PEFT config, and then I'm loading the original Falcon 7B model right here, which is this, basically the base model name or path, which is coming from the config. Here is the Falcon 7B path. So we're loading this Falcon 7B model, and I'm loading it into a 16-bit, in our case, float format from Torch. And then I'm saying that I want to trust the remote code, since this is actually downloading some files that I'm going to show you in a bit that are required to run this model. And then I'm loading the PEFT model using the original Falcon model and then our QLoRA adapter on top of that. So let's run through this. And this is the model that we're going to look at. You can see that the LoRa model is essentially the base model right here. And if I try to upload this, we are going to need to upload the tokenizer, the model, and then the adapter. And this will make it a bit hard to deploy all of this into production. There is probably a better way to do this, and this is to essentially get all of this and call this function of the PEFT model merge and unload. So in this case, we are going to essentially get the weights from the adapter and merge them within the layers of the model itself. And this is going to take or create some layers like linear layers and embedding layers that are based on the LoRa model adapters. Let's see what we have when we do this. So this is now running. It is doing the merging and unloading. And after this is done, we're going to have a look at the model. So you can see that now the LoRa model part is missing, and we have just this RW for causal language modeling. So this is just essentially this part of the model, and the LoRA model and the PEFT model for causal language modeling are now gone, and their weights are essentially merged right within this model. So we have the model that is just a regular HuggingFace model without the adapter anymore. So we can proceed in order to push this to HuggingFace. So in order to push this, this is my current repository. I'm going to push the model to merged, let's say, tutorial. And I'm going to take this and take this, since I've already merged this. So I'm going to start by pushing the model to this repository, and then I'm going to take the original tokenizer from the Falcon 7B, and I'm going to push it into this same repository. Now that the upload is complete, it took around 3 to 4 minutes to upload both the model and the tokenizer. And when we go to the repository, you see that we have the bin files of the model, the index.json file, and then we have the tokenizer config along with the tokenizer. And if you go to the generation config, you see that we have the beginning of sequence token ID and end of sequence ID. Also, we have the transformers version. But if you go to the config itself, you see something that is currently not going to work. You see that we have a reference to another repository for all of the models or all of the supporting files that we need. And for the supporting files themselves, I'm going to take those from the Falcon 7B repository, but the fixed config is available right within the MLExpert IO tutorial for the deploy large language model to production. And here I'm going to simply get this, edit it, and I'm going to paste in the updated configuration, which is essentially taken from the Falcon 7B repository, but it is also pointing to the correct files that we're going to just upload right now. So this is the config. Okay, so now that the config is working great, I'm going to take the other two files that we're going to need, the configuration RW from here, which is essentially taken, I believe, from Bloom. Yeah, this is a Bloom configuration that the authors of the Falcon 7B are using. So I'm going to take this, copy it, and I'm going to go here, add a new file, and I'm going to say configuration underscore rw dot py, and I'm going to paste it in. I'm going to commit that. And after the configuration RW, I'm going to also take the modeling RW, which is again a large file, which is again taken from the Bloom project, I think. So I'm going to name it modeling underscore rw.py. Let's paste in the code. Okay. So I have a typo within the file. So I'm going to fix that. It's modeling with double L, I believe. Let's double check. I'm going to just copy this file name and paste it in here and commit the changes. All right, so now this should be all fine. So I went ahead and restarted the runtime. Let's try to download the tokenizer from this repository and then the model itself. So it is downloading the modeling RW. And then it is starting to download the model itself. So it appears to be working. Our model is downloaded and completely loaded. So it takes a bit of time to download the files themselves. And this, of course, depends on your internet speed. And in this case, we have downloaded the files within 3.5 minutes, and the model is loaded into the GPU. Next, I'm going to create this generation config, which is very similar to what we did in the previous videos. And one of the nice things about these types of models is that you can wrap it within a pipeline from the transformers library. In this case, we're using the text generation pipeline. So I'm going to run the pipeline through this, and you are getting a warning for that. Most importantly, RW for causal language modeling, it's not supported. This is just a warning, and it is currently not officially supported, but as you can see, as you will see, this appears to be working just fine, at least for now. So the prompt, how can I create an account? Let's run this through the pipeline, and I'm going to pass in the generation config also. So this is going to take and do an inference using this prompt. It's going to tokenize it, and then it's going to run the tokenized parts through the model. Let's see what the result is. We have this generated text within a list. So this is just a JSON, and just to have a look at the result, we have the prompt, and this is the response. To create an account, click the sign up button on the top right corner of our website, etc. So it appears to be just the same response that we had in the previous video. So far, everything is looking perfect. For the deployment itself, we are going to use the HuggingFace Inference Endpoints. In this case, this requires for you to put in your debit or credit card, since this is a paid service and it's paid by an hour or minute. I'll show you what our GPU cost is going to be for our instance. Keep in mind that the deployment strategy might be very different when you're using another provider. For example, you can upload or deploy on AWS or other provider, and you can basically orchestrate the whole pipeline for deployment on your own. But inference endpoints appears to be working great for these types of models, and it appears to be a very fast way to deploy something behind an API. The documentation site for HuggingFace Inference Endpoints provides a very nice overview and step-by-step instructions on how to create and deploy your model from the HuggingFace model repository. You can see that they have a very nice chart, which essentially tells you that you're getting your model from the repository. Then it builds a container, and then this container is deployed on something like Docker Hub, AWS, or Azure, or Google. So these are the options that you have. In order to run through this, we are going to have to add a bit more files. In this case, we are going to add this endpoint handler. So let me just restart this, and let's see what this does. So I'm going to run this. So this handler is going to be responsible for loading the model and the pipeline, and then generating a response based on the API code that we are going to pass in. And this is essentially getting the tokenizer, the model, our generation config, and then the whole pipeline that we're going to use. Pretty similar to what we already did. And then there is this call function or method in which we're going to pass in some inputs. In our case, this is going to be the data. And then we're going to run through all of this, the pipeline. And this is the result that we're going to get. So let's run this. And I'm going to get this to run with our model. So this is going to go ahead and load the model into memory, as we've already did. Since we've already downloaded the model, this shouldn't take so much time. This is just going to load the model into the memory or the GPU. So next, I'm going to test out the handler itself, and I'm going to run this, which is going to create a prompt and then create a dictionary with the inputs, since this is the key that the handler expects right here. And I'm going to get the prediction, and I'm going to print it out. So while this is running, I'm going to take all of this code within the cell right here, and I'm going to go to our file or our repository, and I'm going to add a new file. and I'm going to call it handler.py. And I'm just going to paste in all of the handler code right here. I'm going to commit it. So this is going to be responsible for taking the API requests. And the next thing that we're going to need is, let's see. Yeah, this is the response, what we had thus far. So pretty good. The next thing that I'm going to need is this requirements.txt file. This is also available right within the ML Expert IO tutorial. So I'm going to add this file as well. Okay. Now we're ready to deploy our model, and I'm going to use the original repository that I've created, which is exactly the same that I've been using throughout this video. So in order to deploy, you just have to click deploy, and then you have a couple of options. The first one is the Inference API, which is essentially an easy way to deploy your model, but unfortunately, this only supports models up to 10 gigabytes of VRAM. Next is the inference endpoints, that the one that we are going to use. You have Amazon SageMaker Spaces in order to build a Gradio app, and then Azure ML from Microsoft. So I'm going to use inference endpoints, and if you click on this, you'll be taken to create new endpoint page. And here I'm using the repository. It's automatically populated for you. And this is the endpoint name. I'm going to leave this one as it is. And for the instance type, I'm going to choose small instance, since this is going to run on a T4. We've tested that. This is running on AWS in our case, and it is in North Virginia. So for the advanced configuration, I'm going to use a custom task. Framework is going to be left as PyTorch. And for the container type, I'm going to use default. So this will allow us to add the custom handler we've already added as the handler.py. And for the security level, I'm going to put in protected, since I want to use a HuggingFace token for authentication. And this is the estimate of this instance. It's 60 cents per hour. So this is pretty much all of the configuration that you need. I'm not going to enable automatic auto scale to 0. But if you want to, you can essentially say that after 15 minutes of no activity, you're going to scale down the instance, but I'm not going to do that. And if I hit create endpoint, this should create this new instance for you. And it says that is protected instance. It has a custom task. It is revisioned as the last repository hash or commit. And this is pretty much the GPU small instance. So this is now being initialized. After the instance is initialized, you should get that the instance is running. Also, you should get your endpoint URL. In this case, this is an AWS URL, since we are using that for the endpoint. And here, actually, you can try out the inputs. And in our case, I'm going to take this. Let's say something like this. And if you compute this, this is going to take your request and pass it into the handler through the pipeline. And you're going to get this response from your API. So it appears to be working, which is great. Let's have a look at the logs. So one of the important things here is to check your repository ID, that is the same as the one that we've added in at the start. Also, you can see that it is installing the custom dependencies, Torch 2.0, the latest version of the transformers library, etc. So the requirements txt is actually installed properly. And then you can see that at the end you have this info model initialized successfully, and we have the warning for not supported text generation, even though it is currently working just fine. And this is the logs for the posts to this API. So let's see how you can call this model. I'm going to import the requests library, and I'm going to pass in the URL that is the same from the API point or the inference endpoint. And then I'm passing in an authorization token, which is my HuggingFace token. And here I'm passing in the prompt. So this is the payload that we are going to send. And if I post this request to the URL with the payload and then the correct headers for the authorization, you can see that we are taking roughly 8 or 9 seconds in order to get a response from our API. Probably a faster GPU and a stronger machine is going to produce better results. But this for 60 cents per hour, I think is a pretty amazing result. So if we look through the response, you see that this is exactly the same thing that we got before. And if I just print out the generated text, you see that again, we have the correct response or the same response that we did when we were trying the model itself. So this is it for this video. We've seen how we can get our fine-tuned Falcon 7B model and how we can merge it with the QLoRA adapter that we used for the fine-tuning. Then we've seen how we can create a Hugging Face repository. And finally, we've used this same repository on the inference endpoints in order to deploy the model to production behind a T4 or a small GPU instance. Also, we've seen how we can query or how we can get responses from the API based on the request libraries in Python. Thanks for watching, guys. Please like, share, and subscribe. Also, please consider joining the ML Expert Pro subscribers in order to get full access to the text tutorial of this video. Please also join the Discord channel that I'm going to link down in the description below. Thanks for watching, and I'll see you in the next one. Bye.